In this lesson, you will learn to simplify expressions involving radicals. Now, to simplify radicals, for example, the square root of 2 times 2 times 2, what I can do is I can look at the index of the radical. So for example, this index is an assumed 2 if it's not written. And so what I do to simplify is I can look for groups of 2 items within the radical. So here we see 2 2's inside of the radical. So because I have one group of 2's, what I can do is I can pull out 1 2 on the outside. So what I'm left with would be a 2 times the square root of 2. Okay, here's another example. The index is an assumed 2, so I'm looking for groups of 2 items. There's one group of 2 and another group of 2. So because I have one group here, I can pull out 1 2. And here's another group, I can pull out another 2. And I'm left with nothing on the inside. So what I have is 2 times 2, which is 4. And this one makes more intuitive sense because if we take 2 times 2 times 2 times 2, we get 16, and the square root of 16 would be 4. So this demonstrates that this does work, that it's a true statement. And we can continue this for any number of numbers inside the radical. There's one group, there's 2 groups, so I pull out 1, 2, and then another 2, and I'm left with now just 1 2 on the inside. So I have 2 times 2 on the outside, which is 4, and then as a 2 on the inside. Here's one more. Here we have 1 group, 2 groups, 3 groups, nothing left on the inside. So I have 3 groups, 1, 2, 3. I pull out 3 2's. So I have 2 times 2 times 2, which would just be 8. Now this can work for multiple sets of numbers. So let's say here we have 3's and 2's. The index is an assumed 2, so I can pull out groups of 2 items. Here is a group of 2 3's, here's a group of 2 2's. So I can pull out 1 3 because I have one group, and I can pull out 1 2 because there's another group. So my solution would be 2 times 3, or 6. And yes, it makes sense because 3 times 3 is 9, times 2 is 18, times another 2 is 36. So the square root of 36 would be 6. But what I'm demonstrating here is the concept that I can pull out things outside of the radical. Here we see a group of 2 3's, so I can pull out 1 3. Here's a group of 2 2's, so I can pull out 1 2. And I'm left with a 3 on the inside, so I have 2 times 3 is 6, and a 3 on the inside leaves me with 6 times the square root of 3. Here we see a group of 3's, here we see a group of 2's. We can pull out 1 3 here. We can pull out 1 2 right there. So we have 2 times 3 times the square root of 5, which gives me 6 times the square root of 5. One more, here we see 3 3's and 2 2's. But notice the index is different. The index is a 3. So what I'm doing is I'm trying to find groups of 3 items. So here we see 1 2 3 3's. So I can pull out 1 3 because I have one group of 3's. And then I'm left with 2 2's on the inside. So my solution would be 3 times the cube root of 2. Now what I've shown you is a way to simplify radicals. And there are 2 ways to actually think of simplifying. So you have the first way that I showed you, but then there's a second way you can think of it. And this way is helpful when you have something that's not broken down already. So the other examples, you had the number in the radical, which is the radicand. The radicand was already factored down for you. But here we see we have just a 75 on the inside. It's not factored down or broken down for you. So method 1 way of simplifying this would be to factor this down completely. So 75 can break down as 3 times 25, and then 25 can break down as 5 times 5. So this can break down to be the square root of 3 times 5 times 5. And then from here we see that we have 2 5's So I can pull out 1, 5 because there's one group of 5s. And there's a 3 on the inside, so my solution would be 5 times the square root of 3. Now method 2 is kind of a similar concept, where if I have the square root of 75, what I can do is I can break it apart as 3 times 25. Because when I have it like this, we have a property of radicals that says if you have multiplication inside of the radical, I can break it up into two radicals, the square root of 3 times the square root of 25. Just like with division, right? If we have the square root of, let's say, 4 over 9, we've learned that we can break that down to be the square root of 4 over the square root of 9. So with division, I can break it apart. With multiplication, I can also break it apart. So once I get to this point right here, to the 25, I then separate it into two radicals, where now the square root of 25 is going to be 5. So what we have is the square root of 3 times 5, or we can say 5 times the square root of 3. So either way works. So whichever is easiest for you, you can use that method. I'm going to show one more example like that, where I'm going to illustrate both methods. So once again, the 24 in this case can break down. We have a product of 2 times 12. The 12 breaks down as 2 times 6. The 6 can break down as 2 times 3. So what I have is 3 2's and a 3. So then to simplify, I can pull out one group of 2's. And so I have 1 2 on the outside, and then 2 times 3 on the inside. Method 2, you take the 24 and you try to figure out what is a perfect square that I can divide 24 by. So if you think, you can conclude that 4 you can divide 24 by. So you get 4 times 6 equaling 24. So now I picked 4 because I can break the 4 apart into two radicals, where I have the square root of 4 and the square root of 6 that are separate now. The square root of 4 is 2, so my solution would still be 2 times the square root of 6. So either way, we get the same solution. Now when you deal with fractions, we've already said that you can break apart the fraction into two radicals, where we would have the square root of 3 over the square root of 16. And the square root of 16 is going to be 4. So my solution would be the square root of 3 over 4. And it's important to do this because this is a standard way of writing radicals, where, yes, this is one way to write the radical, here's another way to write the radical, and here's a third way to write the radical. But the question is, if you're comparing answers, how do we know if we have the same answer? So there's a standard way of writing your solution. And that standard way of writing it is where there is no denominator inside of the radical. So we see here the 16 is the denominator, but it's inside of a radical. So no matter what, to simplify, I need to get rid of that radical in the denominator. So here it was pretty simple, just break it apart, and we have the square root of 3 over 4. But there are times when you will need to do something else, and that's what we call rationalizing the denominator, where something like this, you have the square root of 27 over the square root of 3. Well, the square root of 3 is not a perfect square, so I can't just take the square root of 3 because it doesn't work. So in this case, one way that I can rationalize the denominator is kind of going backwards, where we said we can separate a radical into two parts when you are dividing or multiplying, but the same is true going the other way, where I can combine two radicals that are being divided into one, where now I have the square root of 27 over 3, all within one radical. Then 27 over 3 is 9, and the square root of 9 is 3. So my solution to this entire problem is going to be 3. Here's another example, where this one, when you break it apart, you have 50 over 49, but the square root of 49 will simplify right away to be 7, but this numerator needs to break down further. Well, the 50 can break down to be 5 times 5 times 2, and I can pull out a 5 because I have one group of 5s, and I have a 2 left over on the inside. So make sure that even though the denominator might simplify pretty quickly, make sure you also simplify the numerator as well. Now here's an example where it's not going to simplify easily. Here we have the square root of 9 over 5, and this is not in the standard format because we have the denominator inside of the radical. So what I need to do first is separate it into 2 parts, the square root of 9 over the square root of 5. Now the question is, how do we get rid of that square root in the denominator? When they're combined into one radical, you can't reduce. When you separate them, you cannot take the square root of 5. So the question is, how do you get rid of that square root in the bottom? Well, we've said before that to get rid of a square root, we can do the opposite of square rooting, which we've discussed would be squaring. Squaring and square rooting are opposite operations. So to get rid of the square root, I need to do the opposite of square rooting, which is squaring. Well, what does it mean to square something? Well, that means you're multiplying by itself. So what I'm going to do is I'm going to multiply the square root of 5 by itself. So multiply by the square root of 5. But I can't just do that because I'm changing the entire solution. So what I need to do is actually multiply the numerator by the same thing. Because what I'm doing is essentially multiplying by 1. Right? The square root of 5 over the square root of 5 is a fancy way of writing 1. When you divide them, they would cancel and leave me with 1. And when you multiply by 1, it does not change the original problem. So I'm going to multiply the top and the bottom by the square root of 5. And by the way, the square root of 9 can reduce to be 3. So I guess from this point we could do the square root of 5 over the square root of 5. And then when you multiply the numerator, 3 times the square root of 5, we get 3 square root of 5. And then the denominator, the square root of 5 times square root of 5, would give me 5. So my final solution would be right here, 3 square root of 5 over 5. Here's another example, the square root of 270 over the square root of 6. So now we have 2 ways to simplify when you have a radical in the denominator. One way was multiplying by the radical. So we could do times square root of 6 over square root of 6 to get the square root to be gone. But that's not the best method in this case. We could do that, but it's going to be kind of messy for the numerator. What I'd like to do instead is maybe try to combine into one radical. So when I combine into one radical, 270 divided by 6 actually would divide evenly to give me 45. And then 45 can break down as a product of 3 times 3 times 5 after you factor it. Well, the 2 3s means that I could pull out 1 3. So I have one group of 3s, I pull out 1 3. I'm left with a 5 on the inside. So my solution would be 3 square root of 5. So in this case, combining happens to be the easier method for simplifying. So make sure you can use both methods, because in this case, this method, when you combine, is preferred, but there are cases when you might need to get rid of the radical in the bottom by multiplying by the radical. So we have discussed how to simplify radicals, and we've learned how to work with fractions. Now to finish the lesson, I'd like to explain a little more detail with how to simplify with multiplying. So for example, here we see the square root of 5 times the square root of 5. Now, just like with division we said that we can combine 2 radicals into one radical when you're dividing. Well, same thing with multiplying. We can combine into one radical. So what we can do is we can combine the square root of 5 and the square root of 5 into one radical, where now I have the square root of 5 times 5. Well, the square root of 5 times 5 would be the square root of 25, which would just be 5. Here we see the square root of 2 times the square root of 8. Same thing, we can combine into one radical, where we have the square root of 2 times 8, which is the square root of 16, which would just be 4. So with multiplying, we can also combine into one radical. Now here we see the square root of 3 times the square root of 27. And if you were told to simplify, what you need to do is combine into one radical. So to do that, we combine. We have the square root of 81, which we know to be 9. Now another method of simplifying, and it's not as helpful in this specific case, but you can adapt this to others where it's not as easy to do it this way. So here's the second method in which we can simplify. When we combine into one radical, we can leave it separate, and instead of multiplying together, we can break down the 27 the rest of the way to be 3 times 3 times 3. So now we have two groups of 3's, so I can pull out two 3's. And I'm left with nothing on the inside and just 3 times 3 on the outside. So my solution now would be 9. So either way, we can get the same solution. In this case, method 1 is easier, but there are cases when method 2 will be easier. So here's one of those scenarios when method 1 might not be as easy. Because with method 1, we combine into one radical, we get the square root of 90. Well, 90 we can break down to be a product of 3 times 30. 30 you get 3 times 10, and 10 you get 2 times 5. So what we have is going to be 3 times 3 times 2 times 5. And then we can pull out 1 3 because I have one group of 3's. And now I'm left with 10 on the inside. So my solution would be 3 times the square root of 10. Now method 2, like we said, is when we combine into one radical, we don't take the time to multiply because I know I'm going to have to break it right back down anyway. So instead of multiplying to get to 90 and then breaking down like we did over here to get 3 times 30, we can just start here at 3 times 30 and break down the 30 to be a product of 3 times 2 times 5. So now we have the same thing. We can pull out a group of 3's. We're left with a 10 on the inside. But notice we're saving ourselves one little step by not multiplying here because I'm just going to break apart the 30 anyway. And actually there's a third method, and it doesn't matter which method you use. Pick one that's easiest for you, and just be aware that there are multiple ways that you could do this. So method 3 would be combining, and then instead of breaking it apart to be 3 times 3 times 2 times 5, I can break it apart to be 9 times 10. And then the square root of 9 is a perfect square. Right here is a perfect square. So I can separate that and get the square root of 9 times the square root of 10. So then from here, the square root of 9 is 3. So my answer would be 3 times the square root of 10. So either method is okay. Just pick one that you are comfortable with and get the correct solution. Now just one last example to point out as we close this lesson, and that is if you have numbers on the outside of the radical and then numbers on the inside of the radical. If you have something like this and you're multiplying, I need to multiply the numbers by themselves separately. So the 2 times 4 would give me an 8. And then I multiply the radicals together, where I have the square root of 3 times the square root of 3 would give me the square root of 3 times 3, which would just be 3. So we have 8 times 3, which would give me 24. So be aware of how to multiply, how to divide, how to simplify, and how to rationalize fractions as well. And that concludes our lesson for today. We will see you next time.